Organic chemistry MCQs. In which reaction is the water acting as a acid, Laurie Bronsted acid? Acids are proton donors, so in which reaction actually the water is donating proton, that you have to work out. So when you see like here H2O become H3O, so it is accepting proton, so it is acting like a base. H2O, HSO4, it just combine here, like dissolved sulfur trioxide becomes sulfuric acid. So it is forming a sulfuric acid, but it is not acting as an acid or a base water itself. But in H2O, NH4 plus OH, so means water has donated proton to ammonia. So this will become ammonium ion and the OH ion is left in the water. So in option C, water is acting like an acid. Because acid, the term acid means it's a proton donor. It is donating proton. So in option B and D, it is actually dissolving the acidic oxide such as sulfur trioxide and sulfur and carbon dioxide to form an acid, but not acting as an acid, dissolving an acid in B and C, B and D. Which of the following compound has both optical and EZ isomer? So if you want to check the optical isomer, you have to check the chiral carbon. And for EZ isomer, you have to see the carbon which are having a double bond. There should be different groups attached to them. So when we check geometrical is possible. This one geometrical is not possible because two identical groups are attached to a carbon with a double bond. Here, this also geometrical possible. And here also geometrical possible. Then optical, there should be a chiral carbon. So this is not a chiral carbon because it has 3 hydrogen. The carbon-carbon double bond can never be a chiral carbon. So this is not a chiral. What about this one? Cannot be a chiral carbon. This one cannot be. So it cannot be A. Then when we check this one, cannot be a chiral carbon. This cannot be. This carbon-carbon double bond cannot be. And even it is not a geometrical. So we don't have to check B. What about C? This is not a chiral. Carbon-carbon double bond can never be a chiral. And this also not a chiral. This is not a chiral carbon, but this one is a chiral carbon. How? Because hydrogen, bromine, then CH, and then CH3 is attached. So there's one chiral carbon. This is not a chiral because the carbon-carbon double bond. Yeah, second one, yeah, you're right. This one, this is a chiral carbon, but the thing is that you're right, in B, this is a chiral carbon, but this is, I mean to say, it was not geometricalized. Like from the beginning, we know there's no geometrical. This is a chiral carbon, that's right, but it is not geometrical. So it has optical isomer, but not geometrical isomer. To be a chiral carbon, 4 different groups should be attached to a carbon. Which of the following react with HCN to make a racemic mixture? So to form a racemic mixture or a racemate, it should have a chiral, first thing, when the product is formed, the product should have a chiral carbon. That is the first thing. So when HCN is attached, so this will become, so when the product will be formed, like this is HC double bonded with O, methanol, this is a methanol. So what will happen when HCN is attached? So one will get CN, another one will get OH. The double. So this is not a chiral carbon. Why? Because two identical groups are there. So this will form a product, but not a chiral. There's no chiral carbon. So if there's no chiral carbon, definitely there cannot be a racemic mixture. So when we check for the second one, ethanol. If this was ethanol and HCN is attached, so CN will be attached one side and the double bond will turn into a single bond and OH. So this is a chiral carbon. There is a chiral carbon. So means this will show a optical isomer, or if it shows an optical isomer, it means definitely it will have the racemic mixture because the carbon as trigonal planar is there. Option C, both sides it is CH3 is attached. So if both sides CH3 is attached, so it will not form a chiral carbon. Same thing C2H5. So in place of CH3, if it is C2H5, it will not form a chiral carbon. So if it's not forming a chiral carbon, it cannot have an optical isomer. And if it's not an optical isomer, so it cannot have a racemic mixture. Which of the following is a redox reaction? A redox reaction happen when aldehyde are usually aldehydes can be oxidized. So ethanol reacting with toluene reagent, ethanol will be oxidized to ethanoic acid and a toluene reagent. It reduction happen in a toluene reagent. So this is a redox. Ethanyl chloride react with ammonia. It is not the redox reaction. There is no change in oxidation number. This will result in a formation of the C double bonded with O and Cl is there. So this will form amide. Amide is there because C double bonded with N plus HCl will be there. But there is no change in oxidation number. So this will NH2 will take position of Cl and Cl with hydrogen. So amide and HCl will be there. Ethanoic acid react with ethanol. So again, it is not a redox reaction. It is esterification. And ethanoic acid with sodium hydroxide. So sodium ethanoate, it is a neutralization reaction. So A is actually a redox reaction in which aldehyde will be oxidized and toluene reagents will be reduced. Toluene reagent or also silver mirror test we can also say. As you can see here, warm each compound Fehling or Benedict solution is when we have copper 2 is there. It will change its color from blue to red. Precipitate will be formed. Sodium carbonate is a test to check the presence of acid group. 2,4-dinitrophenyl is added to test the presence of the carbonyl group, like it can be an aldehyde or it might be a ketone. And if you add water drop by drop to each compound, usually like if we have amide, it will give a misty fumes because it reacts at room temperature. So which test would distinguish propanol with propanol? So propanol can be oxidized by Fehling or Benedict solution, but propanol cannot be. So which test can be used? So we can use test A to distinguish between. So for 7, A should be the right answer. Because with sodium carbonate, there is no reaction. And add drop by drop each compound, that is usually for acyl compounds. Which test would distinguish between aqueous ethanoic acid with ethanol? So ethanoic acid, because acid can react with a carbonate, give fish. So which one is used? So B can be used. So that's why B will be the right answer for this. Which test would distinguish ethynyl chloride from ethanol? So ethynyl chloride from ethanol, what we can do? So we can just add water because acyl chlorides give a misty fumes with water. And about this one, so sorry, I misread. I thought it was propanol because it is alcohol is there. If I want to distinguish alcohol from the carbonyl group, then 2,4-dinitrophenyl hydrogen I should use. I thought it was propanol and propanol because I was just in a reading. I did not focus it on whether it's an alcohol or aldehyde. That's why. Okay. So if it was a propanol, Al was there and propanol, yes, A will be the right answer. But because it's an alcohol, so how I can distinguish alcohol with a carbonyl group? I can use this 2,4-dinitrophenyl hydrogen. When propanol react with iodine in the presence of a sodium hydroxide, a solid product is there. So propanol, it is actually a yellow precipitate or iodoform reaction. So the iodoform, it will form triiodomethane. So B will be the right answer. And this is always the case when a methyl group is there next to carbonyl group. Like if we have a methyl group next to carbonyl group and we add iodine and sodium hydroxide, it will result in a formation of triiodomethane, which is a yellow precipitate. Which of the following reaction mixture are warm, which will contain ethanoic acid as one of the product? So it's like when you warm ethyl methanoate and sodium hydroxide. Look, if ethyl methanoate is there, it will form ethanol plus methanoic acid. And that methanoic acid will react with sodium hydroxide. So even the product is not correct. Ethyl methanoate plus dilute sulfuric acid. So again, what it will result? It will result in a formation of a methanoic acid. Methyl ethanoate, it will form methanol plus ethanoic acid, but that ethanoic acid will react with sodium hydroxide. So you don't get ethanoic acid. But if it is a methyl ethanoate in a dilute sulfuric acid, so the product will not react with any substance. So as a result, it will remain as ethanoic acid. In question 10, the spectra of the compound with the formula CH3CH double bond, CH3CH OH and CH3 can be distinguished. If we work out the mass of these two, they have the same molecular mass, so we cannot distinguish. The molecular ion peak cannot be used to distinguish them because they have the same masses. But the value of mass to charge, that cannot be distinguished. Presence of the fragment CH3, this will like 15 is there, 15 means CH3. So this will also give 15, this will also give 15. The presence of the absorption of the OH both have OH, so we cannot distinguish with OH. But the number of the peaks in NMR, because they have different hydrogen environments, this will have like 1, 2, 3, 4 hydrogen environment, and this will have like the number of the peaks in NMR, like how we will know. This is CH3. This is CH. OH is there. And this is CH3. So these two CH3 are identical. So this will be one peak. This is a second peak and third peak. So this will give 3 peaks. And this will give 1, 2, 3, and 4 peaks. So using the number of the peaks, we can distinguish them. Which of the following has 2 singlet? So to work out the singlet, we have to check the neighbor. If it is C double bonded with O and H is there, so this is only one singlet is there. What about methanol? So first, how many hydrogen environments are there? 2 hydrogen environment. So these hydrogen next, the neighbor does not have directly, because whenever oxygen is there, the carbon is not there. It means neighbor hydrogen will count as 0. Like neighbor hydrogen is not there, neighbor oxygen is there. So this will be 0 plus 1, it will give singlet. Same thing, this neighbor is no hydrogen, oxygen is there. So again, we'll call singlet. So there is no coupling happen because the neighbor is oxygen. So this will give us 2 singlets. We need 2 singlets. This will also give a singlet, but it will be 1 singlet. This will also give a singlet, but 1 singlet. NMR of 2,2-dimethyl propane contain, look, neighbor does not have hydrogen. Neighbor does not have hydrogen. Neighbor, all CH3 are identical and neighbor does not have hydrogen. So what does it mean? It will have a singlet and only one singlet will be there because one hydrogen, number of the peaks are one because of the hydrogen environment and singlet because of the neighbor does not have any hydrogen. So this is about the organic chemistry questions. So next session we will start unit 5.